Hello everyone. Can everybody hear me? Okay.
Yes.
Okay. So we will solve some problems about file processing and functions today. We may start actually with function problems because they are the majority of this PS, and I think they are the most recent topic questions today. So we have the first question. This question wants us to write a function which calculates the area of a circle and prints its output. And pi is given as 3.14. So we should first of all define a function, and let us write the function named area of circle. And today we will use something like the argument or the parameter of a function. What is a parameter? A parameter is how can I say that? A number or a text, etc., a variable which is used in the function to calculate, to give its output. So our parameter is radius in this question. So I can write radius and this sign. So as we know, the area is defined as pi times r squared. So radius to the power of 2. So pr squared should give us the area function, area variable, sorry, and we are returning the area. No, sorry, we are printing the area output. And for this function, we should have an input of this radius. So I can call it r, and we may use an integer for this and input. So as we area of the circle and r. So what are we doing in this function? So the user enters an output named r, and it is converted to an integer from a string. So we are firstly assigning a string there, and then the area of circle function takes this r value as a parameter, and here it is radius, and then the area variable is named pi r squared, and the area is printed. So let us run this. And for example, we can put a radius 10, and it gives us, as you can see, pi 3.14 times 100, and which is the square of this radius. So this is a basic question, and we can go on with the third question now. It's a question still on functions, and we will also use the parameter feature of functions in Python. So what does this question say us to solve? We should write a function that returns the body mass index. It is defined as kilograms divided by a meter square by using the equation 1 inch is equal to 2.54 centimeters. The input is taken as the weight input is taken as a float and in kilograms, and the height input is taken as a float in inches. And the results of this function should be printed after two digits after the decimal point. It should like maybe something like 20.54. It shouldn't be like that. There shouldn't be many numbers. It should be like this. So let us continue with defining a function. First of all, I can name my function body mass or BMI. And what are our parameters here? I can call weight as W, and I can call the height as H. So, and before all of that, I can write the inputs as weight, float, input, height, load, input. So what should we do here? The thing is that the weight is, I can write weight in and sorry, height in, weight is kilograms. Okay. So, and BMI, 8 kilograms. So, this function takes the weight in kilograms as a parameter W and the height in inches as a parameter H. So, first of all, it should convert this H value, the height in inches, to meters to find the real equation of this body mass index formula. So we can assign a variable named height meters, and this takes the height in inches as h, and it is multiplied by 2 times 4 to reach the centimeter, and it should be divided by 100 to reach meters. So let us continue with kilograms. Kilograms is directly taken by the function. This is directly called by the function. So we can directly use it to return our variable here. So we write return, and we should implement the body mass index formula. It takes the weight in kilograms, and it is divided to height in meters. To the power of 2. As I can see, there should be a problem here. Okay. And then it prints this function's returned value. And I can also remind that return value is a returned value is this, and this value is called by the function right here in this print function. So if we write, for example, here the print function, then we can just write like this, and it prints the output in the function. But this assignment wants us to return it and print it then. So I can make an example. We should give first of all the kilograms, for example 80 and 70.7661, and it is given, as you can see, 24.7 blah blah blah. So but the question wants us to reduce the number of digits after the decimal point to 2. So it should stop when it is until the second digit 6. So how can we do this? We are doing this by an operator, just like this. And this operator, the operator with percentage signs, reduces the digit number after the decimal point to 2. So let us run this function again and give the same inputs. As you can see, we have now the 24.76, and there are 2 digits after the decimal point, so it is a successful operation here. Are there any questions about this? These 2 questions? Okay, then I'm continuing with the 4th question: operations on a two-dimensional plane. So what does this question say us? Take the coordinates as in the form of x, comma y of 2 points, and it's named as A and B, which are located on a 2D plane as inputs, and define them as integers. And we should write 2 separate functions which return the slope from A to B and the distance between A and B points. And the results of these calculations should be printed after returning these values by calling them by also parameters. So we should first write the inputs. So I can write here XA, YA, XB, and YB, just like this. Or nope, not like that, sorry. So we can first the coordinates of the first point A, and these are given as input, and they are split by a comma. So I am writing this dot split function here, and then we are taking the same x and y coordinates for the second one. And the question wants us to define them as integers. So I can direct like that. This. So these three lines of code takes the coordinates first of the point A, then the point B, and these values are split by a comma here, and then these values are converted to integers and assigned to their variables again. So we should, or not should, we can start with the slope function here, and it takes two variables of the first point and the two variables of the second point, and these coordinates can be named as here in this function x1, y1, x2, and y2. So what's the slope? Slope is the difference between the y coordinates divided by the difference by the x coordinates, and we are going from A to B. Then we should subtract the coordinates of A from B. So this question should return y2. This is the coordinate of yb, and y1 divided by x2 minus x1. So this function will call the coordinates of x and y and return the slope from A to B. And I can write here also print slope and directly copy these values here. Okay. Then let's continue with writing the second function. This function calculates the distance between these points. So I can write distance and copy these values also. And it should return the distance. So how can we calculate the distance between 2 points? It is actually just like the application of the Pythagoras theorem. So firstly, squares can be found. Just like this. So this is like the distance from these two y coordinates and the x coordinates, and you can think like that in the Pythagoras theorem we have a squared plus b squared, which is equal to c squared. So you can think this y difference as b or a, and the x difference as also a or b, and we are wanting the value of c. So this is the square of c, this equation. So we can also directly write, instead of writing this square and taking its square root, we have parentheses. So we are adding two parentheses before and after this equation, and we are taking the halved power of this. So actually we are taking the square root of this equation. So this function returns the distance between these two points. And let us write print distance and use these variables. So let us wrap up also again what we have done. We have taken the x and y coordinates of A and also on the other line B, and these values are converted to integers, and the slope function is called in the print function, and these values are assigned as parameters here, x1, yb, so for example, are xa and ya, so on and so forth. And this slope function returns the slope, the difference between y coordinates divided by the difference between x coordinates, and this is the slope of slope between these points. And the second function takes the y difference and it squares it, and the x difference is squared by is the power of 2, and the square root of this expression gives us distance between these points. So we can enter an example here. For example, let us take the first coordinate as 3, x coordinate is 3, and the y coordinate is 4. And we can say that the x coordinate of B is 6, and the y coordinate of B is 10. So it gives us the slope as 2, and we can check it also. 10 minus 4 is 6, 6 minus 3 is 3, and 6 divided by 3 is 2, so this is correct. And the other one can be defined as 36 plus 9, so it is 45. It's the square root of 45, and it seems to be correct also. So we have we can say that we have done a good job here also. So let us continue with the fifth question if there are no questions. If you have any questions, please do not hesitate to ask them. I cannot see your hands or see the chat right now, so you can directly interrupt me.
How did you use the split function for the inputs?
Okay. So this split function is used in the input. So if you are taking two inputs or more of them as with a separator, just like a comma or dot or a space, you can use the split function by adding it after the input function, and it splits these two values as described. As for example, you can use a dot here or a space here, so I can use a dot also, just like this, and run this function again, and 3.4, 6.10 again, and it gives the same values. So this is a how can I say, extra function to the input function, and this is also a really contributive function while you are coding in your further Python studies. Was it a satisfying answer, or I can maybe tell more about it if you want?
That was all, thanks.
Okay, you're welcome. So if there are no more questions, I will go with the fifth question, the ideal gas equation question. Okay, let us continue. So this question says us that we should write a program that involves functions and takes three integers, the volume in liters, the temperature in Celsius degree, and the amount of perfect gas in moles. This program should give us two inputs, the temperature in Fahrenheit and the pressure of this perfect gas. It is given that we should use the equations below and accept the value of R, the ideal gas constant, as the value given right on the right in the PDF file. The perfect ideal gas equation is pressure times volume equal to the amount of this perfect gas in mass times R, the ideal gas constant, times temperature. And there are two expressions about the conversion between Fahrenheit and Celsius, and also the Celsius and Kelvin. These are some units about the temperature. And I should remind you that we are using, or we will use here, the value of pressure in ATM, the atmospheric pressure, the volume in liters, as we have the ideal gas constant here, ATM liters per Kelvin times mole. So I have written this Kelvin equation also for the conversion of Celsius degree to Kelvin, because we will use it in the ideal gas equation, and we will write a function about it. So first of all, we can write our inputs as volume in liters, and we can take them as integers. Yes, it says that. Then temperature in Celsius, and also the amount of gas. Okay. So we will take these inputs, and we will call them as parameters in our functions. So I am defining the first function to convert the Celsius degree to Fahrenheit. It is the first and the easiest function that we will write in this question. Set to Fahrenheit. And we will use the we can write Celc as the parameter. So it should return us the value just like this. So we will multiply the Celc value with 1.8 and add 36 to it, and it will return us the temperature value in Fahrenheit. And I'm just writing print Celsius Fahrenheit. Take this value. So what is doing this function? It is calling the temp Celsius value and taking this value to put it to assign it to our Celsius to Fahrenheit function as Celc, and the Celc value is multiplied by 1.8, and 32 is added to this value, and the value we return is the value of temperature in Fahrenheit. So we can first run this function to observe the change in Celsius and Fahrenheit. So I am writing 10 Celsius. Oh, sorry. We should also write this, but I am now deleting these. Sorry. And run this again. So we are here just checking the first function. And it is giving us 50. That is correct, because 10 times 1.8 is 18, and then we add 32, sorry, and we get 50. So let me continue with the other part of this program. So we should define a program to find the pressure here, and I am writing pressure as the function name, and the volume can be demonstrated as V. The value of temperature in Celsius can be used as Tc, and the amount of gas can be used as N, as we define it in chemistry. So the ideal gas equation says that P is equal to nRT divided by V, as you can see here. And we will implement this equation also here. And I want to add here also I forgot it, the value of the ideal gas constant. So What we will do here is multiply. First, we should write return, and we will multiply n with this value r. I can add copy it here and delete it. It is multiplied by r times. So we should here implement this conversion. Tk is equal to T Celsius plus blah blah blah. So I am writing this also just like this. Tc plus 273.15 is equal to the Tk value, which is the temperature in Kelvin, and we are dividing it to the volume in liters, and just like this. So this part of this function should return us the value nRT here divided by volume as the pressure of this perfect gas, and we can print it like print pressure, and our parameters are volume liters, temp Celsius, and amount of gas. So just let me wrap up this function what we have done here. We are assigning we are defining a function as pressure, and the parameters VTC and are assigned as volume in liters, temperature in Celsius, and the amount of gas in moles, as you can see here. And these parameters are used to be implemented in the ideal gas equation here. So let us continue and run this. I think there are no mistakes here. Okay. So we should write first of all the liter input, for example, as 50. Then the temperature Celsius at 27, and the amount of gas can be written as 8. And the values we are taking are the temperature in Fahrenheit and the pressure in atms. So we can also add these units. The units are important in all of sciences and engineering. So I can write, for example, right, not like this. I don't know the shortcut for the degree sign. Sorry, I'm just writing Fahrenheit, and here atm. So as we re-input these values, so as you can see, the units are also added to your values. I will post these PS questions also as a PDF file, and there will be the example input and output, so you can check them if you solve these questions again after this PS session. So the function part is over. This is the 80% of our problem session, and then we will solve a really basic question about file handling, and then I can take your questions if there are any, and finally we will be over. So if you have any questions about these 4 questions we have solved previously, please do not hesitate to ask these. Okay, then I'm continuing with the file question here. So we are given a text here. This is the first paragraph of the Metamorphosis book of Franz Kafka. It is actually written in German as Die Verwandlung, and it's also very good literature. I'm also recommending that you should definitely read it. So the question says us that we should create a file named samsa.txt and write the first paragraph of Franz Kafka's work, The Metamorphosis. The entire content of this file should be printed. Then the first 2 lines of the file should be printed, and finally an end of paragraph indicator must be inserted at the or appended at the end of the paragraph by creating a new line, and the entire file at the end should be printed as a final file. So what will we do here is that we should first of all clear. I can see my notes. Okay, so we will first of all create a variable, so it can be like metamorph. Okay, so this will be the file's name, and the file should be created as like open samsa text as x. So this x says us that we are taking the file as an so we are not taking the file, sorry, we are creating a file, and this could be R if you want to read the file, or it could be V if you want to overwrite something into this file. And we can write paragraph is equal to open samsa text, and we will now write the paragraph here. We can say paragraph right, and I'm going to copy this text here. The lines are divided also, as you can see, with inverse slash and n. And we are coming back, and we are now closing the paragraph here. So we are closing the text file actually. So what we have done, we have created the file as a variable named metamorphosis, and we assigned it to this, and then we obtained the samsa text file as in paragraph, and the paragraph variable, this is the name of the file, is called with the write function by file processing, and this paragraph, the first paragraph of the metamorphosis, is written to the file samsa text, and then the paragraph is closed. And the first assignment wants us to again read this file. And how can we do that? We are calling the paragraph again, and we can open samsa text dot read, and we will write print paragraph read. So this function will open the paragraph as read only, and it will read these values in the file, and it will print it in the paragraph that reads that should be written. So I'm running this function. So as you can see, we have created a samsa text file here in our project, and this file can be observed like this. We have our lines as we have given in the question, and the file is printed below in the control panel. So what should we do? We should print also the first two lines of this file, and then I am closing the file here, and I will reopen it. PNG, open. Sorry, I am again writing this as read-only, and this opens the file as read-only. and the PNG read line. This is the first, this will read the first line. And this will read the second line, and this will close our file after the first lines are read. So I will run it again. Sorry, okay, someone says existing, so I should delete it. Sorry. And I can run it again. So as you can see here, the first we have printed the file, and then the lines are line by line printed. The first line is as it starts with as Gregor Zamsa awoke on morning, blah blah blah, and the second line is he was lying on his heart as it were armor plated, so on and so forth. So we have completed the second part of this question also, and finally we should insert an end of the paragraph indicator at the end of this paragraph. So I can take this text. I'm opening the same file also, and I shouldn't forget that I should delete this, so we can create it again. So I'm writing A to append something at the end of this file. If I write W here, it overwrites, it deletes the things we have written above on the lines between 3 and 5, and it directly overwrites something here. But I don't want this. I only want that there should be an indicator that we have read all the paragraph, and it's the end of it. So I am writing text dot write end of the paragraph, and I can write it by creating a new line. So it wants us to create a new line here. So I am putting a backslash and n to indicate that there is a new line here, that the text to be written should be appended on a new line on the end of this text file. And then I am closing the text file again, and I will open as it is. Maybe I am assigning Burak Can equal to open some text read and print Burak Can dot read, and after that it should close the file name Burak Can. So we are clear, and I'm running this function again. So what we have done can be seen here. We have firstly printed the entire content of this file, but first of all we have created a file named samsa-text, and then we have written to this empty file the first paragraph of the metamorphosis, and then we have read the entire content and printed it by these lines, and then we have opened it and read the first two lines of this function. Sorry, the text, not function, and at last we have opened it with the append method, and we have written the end of paragraph indicator on a new line by using the inverse slash and n, and then we close it, and then we open it in the read-only mode. And as you can see below, the last version of our file includes the end of the paragraph indicator at its last line. So Ünal wants to ask something. Yes.
I don't understand why we're using different variable names for each file handle as file handles each time? Can't we use a single name and then continue?
You can use whatever you want. It can be it can be the same one. I'm just differentiating it by fun. I can write here all of them as paragraphs. We shouldn't use PNG, so let us use it as paragraph here by all. It does not create a problem here. So I'll delete it. So as you can see, it works also. So I want to thank everyone who attended PS. We are over. If you have any questions, please do not hesitate to ask them. And I am writing also my email to the chat. If you have any questions about the content of this PS and and if you cannot solve a problem related to the subjects that are included in this PS, you can ask these questions always to me by using this email address. The PS is over. If you have any questions, please ask. Okay, if there are no questions, I am closing the Zoom session. Thank you, everyone. See you later.